All right, hi everyone. So this lesson is 11.1.2, and in this lesson we'll be covering how to multiply and divide rational expressions. So remember, I do expect you to actually write these notes down and work through the problems with me in order to just get some of the practice that we're doing. So we'll go through several examples. I'm actually going to start with very basic multiplication and division of fractions. These are two operations of fractions that people often forget or mix up in terms of how to complete them. So let's look at an example with a simple one with multiplication. So let's do 2/3 times 9 over 14. All right, so with multiplying fractions, we know from the last video of simplifying them, we're just multiplying straight across numerator and denominator. So all we need to do here is 2 times 9, and we've got 18 in the numerator, and 3 times 14, which is 42. So now we've got 18 over 42, and all we need to do is simplify. So we need to figure out, how can I reduce this fraction? First of all, we see they both end in an even number, so we can start by dividing both of them by 2 if you want. So 18 divided by 2, so we can cancel that out by 2, and that would be 9. We can divide 42 by 2, and we would get 21. So this equals 9 over 21. Hopefully you're looking at these two numbers, 9 and 21, and recognize that those are actually both divisible by 3 as well. So 9 divided by 3 is 3, 21 divided by 3 is 7. So this actually has a final answer of 3/7. So I know most of you are following that pretty well. I want to go back to the beginning because there's a way to get to 3/7 a little bit more quickly. So this way that I did here is perfectly fine, and this is how I might work through it, but there's actually different ways to approach some of these problems. So let me switch colors here, and let's do this problem again. So what we saw from simplifying rational expressions is that we can make cancellations or simplify numerator and denominator actually before we multiply, which is what we started with originally. But you might look at this and say, okay, I'm multiplying the denominator by 3 in one spot, and I have 9 in the denominator up here. So we could technically do this cancellation first. So I'm going to rewrite it. We could do, so we've got 2/3 times 9 over 14. So I could see this and say, okay, 3 goes into 3 one time, and 3 goes into 9 3 times. So I can, instead of doing 3 times 14, I can actually do 1 times 14 and 2 times 3. But we see this 2 and 14, and we know those will also have a common factor of 2. So when I factor the 2 out of the 2, I just get 1. And when I do 14 divided by 2, I get 7. So now what we have is 1 times 3 and 1 times 7. So we did all those cancellations, which we did up here, before we multiply, and it actually just simplifies to our answer of 3/7. So then we get 3/7. So there's these two different strategies. Do you multiply right away? Don't even think about making any cancellations. Just go straight to multiplication like we did here, and then reduce the fraction. Or you can look at the original multiplication and make some of those cancellations ahead of time, which might end up saving you some time. Either strategy is perfectly fine for that. So let's look at a second problem. That would be part B. Now let's look at division. So let's do 3/5 divided by 12 over 25. All right, so 3/5 divided by 12/25. So when we have a fraction divided by another fraction, there's a couple ways you guys may have been introduced to this. Some of you may have been told this catchphrase, keep, change, flip. So keep, change, flip means you keep the first fraction, change the operation from division to multiplication, and flip the second one. So that's a little bit old school, that keep, change, flip phrase. Others of you have just been taught through CPM actually the strategy, which is multiply by the reciprocal of the second fraction. So we take the first fraction and then we multiply by the reciprocal. So it's the same as keep, change, flip, but it's just using proper math terminology. When I was in school, we learned this little rhyme, and that was when dividing fractions, you know why, flip the second and multiply. Those are all saying the same thing. So when you divide a fraction by a fraction, when you are dividing by any fraction, you multiply by the reciprocal of the fraction. And then we are back with a multiplication problem. And for multiplication, we know we just multiply the numerator and multiply the denominator. So that would be 3 times 25, which is 75, divided by 5 times 12, which is 60. So now we've got 75 over 60, which hopefully you're recognizing both of these end in a 5 or a 0, so they're both divisible by 5. That's the first reduction I would make. So 75 divided by 5 is 15, and, oops here, 60 divided by 5 is 12, which is interesting because, look, then we go right back to 12, even though we just multiplied it by 5, then we reduced it by 5. So this gives us 15 over 12. 15 and 12 are both divisible by 3. So if we factor 3 out of 15, we are left with 5, and 12 divided by 3 is 4. So then we have this final simplified solution of 5 over 4. Now I'm going to go back and do this again because remember with A, we multiplied straight across and then reduced, and then we found that if we actually reduced before we multiplied, we got there a little bit more quickly. Either way is fine. So I'm going to, this first step here going to division, always do that first. So always rewrite it as division first. Or rewrite as multiplication first. So I've got that written out here. So this step we're always going to do, but starting here, we can think of it as in a different way. So when I have 3/5 times 25 over 12, remember we know that when we multiply this straight across, and then in the denominator, we could also make some of those simplifications first. So you see the 5 and 25, and we know that 5 goes into 5 one time, and it goes into 25 5 times. We also know that 3 goes into 3 once, and 3 goes into 12 4 times. So now we've got these two new fractions, 1 over 1 times 5 over 4. So that just gets us to this final answer of 5/4 a little faster. Again, either strategy is fine. If you want to just always follow that process of step 1, multiply numerator, multiply denominator, and then reduce, you can. Or before you do any multiplication, you can do some simplification and then multiply. Either one is fine. So now we're going to move ahead and do some of these multiplication and division problems with actual expressions involving a variable. So let's move into that in example 2. All right, so in our first example, we'll have 4x plus 3 divided by x minus 5 times x minus 5 divided by x plus 3. Okay, so if we follow the first straightforward strategy here, we would multiply the numerators and then multiply the denominators. Before I multiply numerator, remember this 4x plus 3 and the x minus 5, these are a group of things. Think of it as in their own parentheses. So I'm multiplying this whole 4x plus 3 times this entire x minus 5. I'm not just doing 3 times x. So that would mean my new numerator would be that product. So 4x plus 3 quantity times the quantity x minus 5. So those need to be in parentheses. Same thing in my denominator. I've got x minus 5 times x plus 3. So x minus 5 times x plus 3. Now I've got this fraction here, and I see x minus 5 in the numerator, x minus 5 in the denominator. So that's a cancellation I can make, and that leaves us with 4x plus 3 divided by x plus 3. So at this point, Many of you are seeing and hearing this x plus 3, and want to cancel that out. But we cannot cancel those out because this 4 right here. So 4 is being multiplied by x in the numerator and then adding 3. So we cannot cancel out. This is what I see all the time is people either canceling out these 3's because you see 3 over 3 and you think it's 1. People canceling out these x's because you see 3x over x and you think it's 1, and resulting in an answer of 4. So that's a common mistake I see, but remember this numerator and denominator are technically in their own set of parentheses, so we cannot make any cancellation. So this is our final answer. And we do need to make note of the restrictions on x. So here from our final answer, we know x cannot equal -3 because when you add 3, that would leave you with 0 in the denominator. So x cannot equal -3. But we can't forget about our original problem here. We also had x minus 5 in a denominator. Even though we canceled those out, we still have that restriction based on what our original expressions were. So x can't be 3 and x also cannot be +5. Okay, before I move on to another problem, many of you may have started this problem a little differently. Instead of jumping into this multiplication, some of you may have looked at this and seen these x minus 5s. Just like before, if you had recognized this 5 and 25 here, same thing. But in this case, it's the exact same factors. So I have x minus 5 here, x minus 5 here. Remember, think of these as in their own sets of parentheses. So the first thing we could have done is make that cancellation before we even multiply. And when I cancel out these x minus 5s, remember that goes into itself one time, and same within the denominator. So this numerator, instead of x minus 5, is now just a 1, and same with this one over here. So we have 4x plus 3 over 1 times 1 over x plus 3. This gets us to our final answer of 4x plus 3 divided by x plus 3 in a single step, because we made that cancellation before we wrote out the product first. So either way is fine. Again, this second way where you make those cancellations first does tend to get you to that final answer a little more quickly. All right, let's look at another multiplication and then we'll jump to division. So let's look at our second multiplication problem here. And we're going to do 2m plus 3 divided by 3m minus 2 times 7 plus 4m divided by 3 plus 2m. All right, so let's get that written down and we're going to do this multiplication. So before I jump right into multiplying the numerator and denominator like I did up here, now that we're seeing simplifying first is helping us, let's see if we can simplify anything. So I have 2m plus 3, and I don't have that here. Well, it's 3 plus 2m. But we know with addition, we can reverse the order. 2 plus 3 is the same as 3 plus 2. 1 plus 5 is the same as 5 plus 1. So this 2m plus 3 and this 3 plus 2m, that's actually the same thing. So I can think of this as 2m plus 3 instead of 3 plus 2m. Now I have these two factors that are exactly the same, and I can cancel those out, leaving me with a 1 in the numerator here and a 1 in the denominator there. So now when I multiply straight across, I've got 1 times 7 plus 4m, which is 7 plus 4m in my numerator. And the denominator, I've got 3m minus 2 times 1, so we just end up with 3m minus 2. So this is the final result. There's no simplifying or canceling I can do. So this 4m here, again, we cannot cancel with these m's out because these are in parentheses, remember that. But we do need to make note of our restrictions on m. Remember, we can't have any denominators equaling 0. So that means 3m plus or 3m minus 2 cannot equal 0, which means 3m cannot equal, add 2, and then divide by 3, which means m cannot equal 2/3. We also have a restriction from this denominator, 3m minus 2, oh, we just did that one. we also have a restriction from this denominator. Even though we canceled it out, it's still a restriction. That was still a part of our original problem. So 2m plus 3 cannot equal 0, which means 2m cannot equal negative 3 because we subtract 3 from both sides. So m cannot equal negative 3 halves. Some of you may be starting to get from just this original denominator straight to the restriction because you know, okay, I'm going to add 2 and then divide by 3. So you might jump to that 2/3 right away, which is fine. So you don't have to write this out every time, these step-by-step processes. I'm just doing that so you guys are seeing exactly where the restrictions come from. Okay, let's move on and practice this with some division problems. All right, so in our third example here, let's do C. Problem C, we've got x plus 2 divided by 9x minus 1 divided by 2x plus 1 over 9x minus 1. Okay, remember up above when I did a simple division problem, the first step is always rewrite it as a multiplication problem. So the first thing we're going to do is right away, before I do anything else, I'm rewriting this as division. So x plus 2 over 9x minus 1 times 9x minus 1 over 2x plus 1. All right, so just from hearing that and looking at it, we see the 9x minus 1 in both of these. So the smart way to do this would be make that cancellation first, and that'll get us to our final answer a little more quickly. So I can cancel this out because 9x minus 1 in the numerator and denominator cancel out. And that leaves us with x plus 2 over 2x plus 1. And there is no simplifying we can do here. Again, we cannot cancel the 2 here and the 2 here. We cannot cancel the x and the x. It has to be the exact same numerator over the exact same denominator in order to make these cancellations. So this is it. We do need to think about restrictions though. So we have restrictions from our original setup. We have 9x minus 1 in the denominators here. So that means x cannot equal, think about what we would do to solve for when that whole thing equals 0. We would add 1 to both sides, then divide by 9. So that results in a restriction on positive 1 over 9. So x cannot equal 1 over 9. That's one restriction. But we also have this in our denominator once we switch this to its reciprocal. So we also have 2x plus 1 cannot equal 0, which means x cannot equal negative 1/2. So you would subtract 1 from both sides, then divide by 2. So we've got two restrictions on those. So we have the restrictions from the original two denominators, which in this case happen to be the same, and a restriction from the new denominator once you multiply by the reciprocal. Let's look at one last example here before moving on to our final set of problems. So let's do one more division. We've got 15x cubed divided by 3y. That whole fraction is divided by 10x squared times y over 4y squared. So this one's interesting because we don't have any addition or subtraction like we did up here. We've got addition and subtraction. Here is all multiplication in each of the two separate fractions. So again, before I do anything, we are going to always start by taking any division problem and rewrite it as multiplication. So we've got 15x cubed over 3y times 4y squared over 10x squared y. Okay, now we could do one of two different things. We could multiply straight across the numerator and then the denominator. So we could do 15 times the 4 and then x cubed times y squared. We could do 3 times 10 y times x squared y. Or we could do some cancellations across. So again, there's no right or wrong way to do it. Sometimes I like to just instead of simplifying, go straight across and see what we end up with. So I'm going to do that. I'm going to do 15 times 4, which is 60, and then, so I've got 15 times the 4, that's 60, x cubed times y squared. So we just multiply every single term up here together. Same with the denominator. I've got 3 and 10, so that'll be 30, and then y times x squared times y. So the x squared is just still x squared, but that y times y turns into y squared. So now I'm looking at this new fraction where simplifying in terms of variables and these integers is going to be a little easier. So now the first thing, we've got 60 over 30, so we can reduce both of those by 30. So 30 goes into 30 one time, and 30 goes into 60 two times. Hopefully you see this y squared over y squared. We can cancel those because y squared over y squared is 1. So that just turns into a 1. That just turns into a 1. And then we have this x cubed over x squared, and we know, hopefully we're remembering, that we would just take those two exponents, x cubed over x squared, and subtract. So that would result in x to the first. So this whole thing results in x to the first in the numerator. So what does that leave us with? That leaves us with 2 x to the first times 1, so that's just 2x. In the denominator, look what happened. We took 30, and that canceled out to 1 with the 60 up here. The x squared is now gone because we did these exponents minus each other. And the y squared canceled with this y squared, so it ends up being 2x over 1, which is just 2x. And then we have our restrictions. We had y in the denominator here, so y cannot be 0. And we then ended up with x in the denominator, so x also cannot be 0 for that one. All right, whoops. Okay. All right, so let's move on to our final set of problems. Just 2 more problems that I want to show you because we're going to put all of this together from these last 3, this video and the 2 before it. So in our final set of problems, we are going to look at something that's going to put together everything, starting with what we started with in the beginning of this section of this chapter 11, which was factoring. So let's start with this example, 5x minus 15 divided by 3x squared plus 10x minus 8. So that whole fraction divided by x squared, so divided by x squared plus x minus 12 over 3x squared minus 8x plus 4. Okay, there's a lot going on here. In fact, we probably won't do another example after this because if you can do division, you can do multiplication because every division problem here is turning into multiplication. So that's what we can do. We can rewrite it as a multiplication problem first. So let's do that. We've got 5x. Actually, while I'm doing this, I can take this 5x minus 15 and I can easily factor out this 5. So I'm going to write 5 outside, and that would result in x minus 3 right there. And then that's divided by 3x squared plus 10x minus 8. Now I'm switching this division problem to multiplication, which means I'm taking the reciprocal of the second fraction, which is 3x squared minus 8x plus 4 divided by x squared plus x minus 12. So the first thing we've done again is rewrite multiplication as division. I did this basic factoring right here. Now we've got multiplication, and here we can multiply numerators or we can make some cancellations first. Here's what we cannot do. We cannot cancel out 3x squared and 3x squared because those are a part of these whole groups. These are in parentheses, remember. So I cannot make any cancellations unless I factor. So in these problems, if they're not factored, so if you notice all of the problems we've done so far, whoops, they have been in factored form. So these are already factored. If you look back up to B and C, those are already factored expressions. In this problem, I gave you a problem where nothing is factored. It's all adding and subtracting these different terms. So we need to factor first. Okay. All right, so in this last example, I'm going to write this down in all caps. Always, before we can simplify anything, we're going to factor. So again, this is why we started off this unit with a factoring practice review, because there's a lot going on here. So I'm going to start by factoring this one. So I'll just draw a little arrow. So again, we got to go back to these area models to help us factor this. So I know the 3x squared is going to go here, and I know that that negative 8 is going to go here. And it's the 10x's that we're splitting between these two boxes, and this is where we resorted to the area models to help us. So you need lots of space for these problems because you have a lot of factoring going on. So I know that I'm going to look for two numbers that multiply to 3 times negative 8, so it would be negative 24, and those two numbers that also need to multiply or add up to 10. So multiply to negative 24, add to 10. So 24 and 10, what multiplies 24 adds to 10. So things that do that, that would be 6 and 4. So 6 and 4 multiply to 24 and add to 10, but they need to multiply to negative 24. That would mean one of them would have to be positive and one would have to be negative. So, but if one is positive and one is negative, they can't add up to positive 10. So 6 and 4, well, it seems like they might work at first, or at least I thought so. They actually don't work. But another number that multiplies to 24, two other numbers would be 12 and 2. And if one of those is positive and one of those is negative, I can make them add up to 10. That would be positive 12 minus 2. So that multiplies to negative 24 and adds to 10. So then I can put 12x here and negative 2x there. All right, then I can finish factoring. So my 3x's, it doesn't matter where I put the 2x and or 12x and negative 2x, but it does matter where I put that 3, my 3x to get this. So since I have a 12 here and a negative 2 here, only the 12 is divisible by 3, so I'm going to put that 3 down here. So now I've got x out front here, 3x here, which means I would have to multiply by 4 to get 12x, and I would need to multiply x by negative 2 to get negative 2x, and then that negative 2 and 4 multiply to negative 8, so we're good. Okay, I'm going to rewrite my problem. So my first fraction is 5 times x minus 3 divided by, I had just factored the denominator of that, which is x plus 4 times 3x minus 2. All right, now I've got a couple more things to factor. So all I've done is accomplished factoring this. Now I need to factor both of these. So I'm going to start with this one up here. How can I show you guys that? I'm going to do that in the green. So I'm going to factor that down here below. All right. Nope. Okay. So I'm factoring 3x squared minus 8x plus 4. So I'm going to put 3x squared here. 4 goes here. And then since this coefficient is not 1, just like the last one, I'm going to be splitting these negative 8x's right here. But in order to do the area model, remember I'm taking 3 times 4, so that 12 goes up here, and then the negative 8 goes in the bottom. So I'm looking for two numbers that multiply to positive 12 and add to negative 8. multiply to 12. So 3 and 4 do, but those won't combine to -8 if I add them or subtract them. But 6 and 2 multiply to 12, and if they're both negative, they multiply to positive 12 and multiply to -8. So that will work. So we've got -6x and -2x. Those I could have switched those around, but now that the 6 is here and the -6 here, -2 here, then I know that the 3x for this first box down here must be down below. So that needs to be 3x here, which means I would multiply by -2 up there. And then 1x there, which means I multiply by -2 there as well. All right, I have my factored numerator of this second one. So this fraction right here in the numerator, that factors to x minus 2 times 3x minus 2. And then I need to factor this final quadratic right here. So I will do that factoring in, I'll go back to blue. So I'll factor this right here in this area model. Whoops, that's not what it looks like. Okay, so we've got x squared and -12. And this one's nice because the coefficient of x squared is just 1. So I don't need to multiply 1 times -12 here. I just have, well, I can, but this simplifies our process. So we've got -12, two numbers that multiply to -12 and add to 1, since I just have this 1x right here. So that would be 3 and 4, and if I want them to add up to 1, the 4 would need to be positive, and then subtract 3, and that would get me 1, and if I multiply those together, I get 12. So that means I've got 4x here, -3x, and then to finish this factoring I would have x and x, 4 goes there, -3 there. Alright, so I have my final factored form here. X plus 4 and x minus 3. So we have done 3 factoring problems in a single original division problem, and all we have right now is just factored form of our multiplication problem now. So a ton of legwork here, a ton of it. But once you do all of that, the actual multiplication is not so bad, because what you'll find most of the time when you factor is you will see some cancellations that will happen. So we've got x minus 3 right here in the numerator of the first fraction. We also have x minus 3 right here in the denominator of the second fraction. So those will be divided by itself to equal 1, so I'm canceling those out. Any others? So we've got 3x minus 2 and 3x minus 2. That's wonderful. So we can cancel those out as well. You may notice that we have x plus 4 and x plus 4. Can we cancel those out? The answer to that is no, because we're actually multiplying those together. We can't cancel them out. We would if this x plus 4 was in the numerator, but we can't. So we've just got x plus 4 times x plus 4 in the denominator. So looking around, I don't think we have any more things we can cancel, so we can go ahead and just write what happens when we multiply now. So let me get my pen ready. All right, so now I've got 5 times x minus 2 in my numerator. And then in the denominator, I've got x minus 4 times x minus 4. So that would be x minus 4, or x plus 4 squared. And that is it. So a ton of legwork, again, getting from this to this factored form, but once you're there, the multiplication is very quick. So this is our final answer. There's no more cancellations we can make, but we do have lots of restrictions on x. Those restrictions are going to come from this factored form of this problem. So we've got this restriction, so x plus 4, which means x cannot equal -4. We've got this, even though we canceled it, it still matters. So 3x minus 2 which means x cannot equal positive 2/3 because we would add that 2 and then divide by 3. We've got this x plus 4, which we've already accounted for right here because x can't be 4 or negative 4. X minus 3, even though we canceled it, we know x cannot be positive 3. And then we still have one final restriction, and that comes from this fraction, because remember, we had this original problem here, and that means the way that this factored, which ended up being x minus 2 times 3x minus 2, we have to consider restrictions from that as well. So the final restriction on x would come from this whole numerator, which would mean x can't equal 2/3 and x can't equal 2. So comma, x cannot equal 2. So we have 4 restrictions on x for that one. I'm going to stop here because this problem here with this first one that ended up taking 10 whole minutes, any division problem is rewritten as multiplication first. So I was going to do a second problem with multiplication, but we kind of already did a multiplication problem within this. So these problems get very complicated looking, but it's just because all we're doing is factor, factor, factor. All of that factoring first will make for a very simple multiplication process because a lot of those factors will end up canceling out. All right, so this will wrap things up with multiplying and dividing rational expressions, and you should be good to go on that worksheet. All right, guys, see you next time.